good morning, everyone. Today we are going to discuss about IPs, that is inter-process communication in QNX. So this IPC inter-process communication, you are going to learn message passing, designing a message passing system. That is, first one is pulses for that. Next is client information structure, how a client finds the server multi-part messages. Then designing a message passing system. That is the second, designing a message passing system. Then issues related to priority basis. Then designing a message passing system. The third event, the delivery system. Then shared memory. Then about the conclusion of inter-process communication. So what is an inter-process communication? I think this inter-process communication having two process exchange. See, say process A, process B. See, process A is one kind of a thread, process B is another kind of thread. Here the purpose is to control. There is a data and to control it and notification of event occurrence. So here QNX supports a wide variety of IPs. There is QNX core. Here API is unique to QNX or low level, which includes QNX messaging, QNX pulses, and shared memory. The focus of this course module is like POSIX and UNIX, well-known portable APIs. That is, I can see for embedded system, the basic industrial oriented like coding system instance we used to go ahead with POSIX or shell, or it may be Unix or Linux. So here this QNX purely meant for POSIX or Unix system only. And this includes signals, shared memory, pipes, that it requires pipe process, then POSIX message queues, then it requires MQ process, TCP or IP control sockets, that is requires IO soft process, and purely focus of the POSIX IPC course module. So for message passing client server, the server pseudocode create a channel, that is channel creator of wait up a message receiver, perform processing, replay message, replay up, go back for more. Client pseudocode, that is attach a channel, send message, make use of reply. While passing the client, how the message sent to call client status is equal to message sender. COID or COID message is bytes RMSG. There is R message receive message, R bytes receive bytes. So this COID is nothing but it is a connection ID. Yes message is sent message. Yes bytes is message of sending message. R messages there is reply message. R bytes is what size of that what reply message in bytes. The status is what will be passed as message, what a reply, there is status parameter. Here we are going to discuss about a server example. There is hash in glue, there is system neutrino.h. So what happened? How it firstly we need to go ahead with the like for a C language, we are having what header files. There is hash in glue. There is int main void of. Then int chid. Then rcbid. Then my message. Then we need to consider the child network. That is if loop, for loop, while loop, if else loop. Like that we have to process in the form of POSIX or Unix format in our QNX. The designing for message passing message. How do you design a message passing interface? It defines message types and structure in a header file. Both client and server will include the common header file. So all messages with a message type. It have a structure matching for each message type. Finally, we can certify matching replace structure if appropriate. Then about pulses that already I have, we can detail in the next slide also. Anyhow, pulses is a non-blocking for the center, having a fixed size is 64-bit or 8-bit code. It is a unidirectional one and fast and inexpensive one. How the sending pulses may be? There is message send pulse, there is communication ID, there is COID, then what else priority code value. Pulse is a receive just like messages with message a receive or call up. Like what here I need to insist you was see the pulse data will be written to the receive form. Then about the pulse structure. Struct pulse signed character union sigwal then that is the main structure of this. Here code indicates 8-bit code. Value may be that is value member like a union one like union sigwal, long sigwal, void loop, int like that we may declare it. Then about receiving pulses. See how a receiving ID will be RCVID is equal to message received, then child and the message size of message then null. Next about one pulse exercise. See, the create a project is IPC. There we need to copy the checksum server.c from last exercise to pulse server.c. Then uncomment the line in the make file to build the pulse server. Extend the server so that it can now handle pulses as well as checksum. Then run the server, write down or copy the PID and CHID. Run the pulse claim using the PID and CHID. After getting the information, what mean now that after receiving a message, information will be stored in a struct format and get during the message receiver or later using message info, and this will not be updated if you receive a pulse. Shared memory. After getting what setting up a shared memory region, the same physical memory is accessible to multiple processes. There's chat, code, and data, and it may be mapped area, then physical memory address space also. See, here I need to conclude with an exercise with POSIX portable example. I said for embedded system purely if graduates are well good in POSIX, definitely he or she may can work in what my industry level in good mood. There will be more recruitment process also based on that POSIX language. So conclusion to QNX native IPC. Here the architecture of QNX IPC, how to program with QNX message passing, use the advanced features of QNX IPC, how to design a message passing system are well known for the graduates. Thank you all.